Assalamu alaikum. I am Sumbul, lecturer in physics at Sir Syed Government Girls College. Today, in this video lecture, we are going to discuss another form of transistor, that is Jfet. In our previous lectures, we have already discussed what is bipolar junction transistor, its action and its stages. So let's get started. But before this, I cannot forget to acknowledge our Honorable Principal Professor Khalda Parveen for her guidance and encouragement throughout. Jfet is a short form of junction field effect transistor. It is basically a unipolar voltage controlled device because only the majority charge carriers are responsible for the conduction through the device. It consists of three terminals, namely source, drain and gate, and the voltage which is applied at the gate terminal controls the device current, and this is the reason it is a voltage controlled device. Basically, the Jfet is classified into two categories. The first one N-channel Jfet and the second one is P-channel Jfet. And this classification is based on the type of semiconductor material which is used at the time of its fabrication. In an N-channel Jfet, two P-type semiconductor bars are diffused on a single N-type substrate, and as against in P-channel Jfet, two N-type semiconductor bars are diffused in a single P-type substrate. To understand the working of Jfet in this, we will consider an N-channel Jfet. So let's move further to understand the working of N-channel Jfet. We will discuss three different cases under the working of Jfet. So the first case is when no voltage is provided between the gate and the source. So VGS equals to 0, but the supply VDD, that is the source voltage, is equals to the voltage between the drain and the source. So VDS equals to VDD, which is provided between the drain to source terminal. We have clearly seen that the positive terminal of the supply VDD is connected to the drain side and the positive terminal of the supplied VDD is connected to the source side. So the majority charge carrier of the N-type material, that is electron, moves from source side to drain side because these electrons experience attractive force from the positive terminal of the battery to the drain side. This causes drain current ID to flow through the device. We have clearly seen that the drain current is flowing from drain side to source side, as this is the conventional current of the device, and the conventional current flow in the direction opposite to the flow of electrons, and the electrons are moving from the source side to drain side, and this is the reason why drain current is flowing from drain side to source side. Now question arises why both the depletion regions are broad at the top but are narrow at the bottom. The reason behind this is that basically an N-channel exhibits non-uniform resistive nature towards the drain current flowing through the device. Let's see how. Suppose the N-channel is comprised of these three resistances and initially the voltage at its particular point is 4 volts, and in series the value of these 4 resistance are equal. So the drop at this particular resistance is 1 volt. So the resistance at this point is 3 volt, and so leading to 0 volt at the source side. Also at the gate terminal is at. This causes the PN junction to get reverse biased. However, this drop is more towards the drain side. This is the reason why the depletion width is penetrated more towards the drain side as compared to the source side. Now let's move towards our second case. When VGS is less than 0, and VDS is equals to VDD. Here in this case, some external reverse bias voltage is provided between the gate and the source terminal, and also VDD is provided between the drain and the source terminal. So due to the reverse applied potential between the gate and the source terminal, the width of the depletion region increases with the increase in the width of the depletion region. Less number of charge carriers will be able to flow through the channel, and this resultancy will decrease the drain current. So in this case, we may say that the potential applied at the gate to source terminal controls the drain current through the device. Now let's move towards our last case. Here in this case, we have further increased gate to source applied voltage. So with the increase in the reverse applied voltage, the width of the depletion region will increase more. So the point reach when the two depletion region meet each other, and this leads to the completely cutting off the current that is flowing through the device. So in this, we can say that the field generated due to the reverse applied potential controls the current that is flowing through the device, and this is the only reason why Jfet is called junction field effect transistor, that is a voltage controlling device. Right. So that's all for today. Thank you so much.